And we've been simplifying rational expressions. A rational expression is a fraction, right? A ratio of numbers. So we're talking about more fractions, and we're going to add and subtract these. And so let's start with a simple example, like you've done this kind of thing before, right? So you want to get an LCM, a least common multiple of 8 and 12. And so multiples of 8, would be like 8, 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is 32, and 40, and so forth. Multiples of 12, 12 times 2 is 24, 36, 48, etc. What's the lowest common multiple? It would be 24, right? So we could get a common denominator of 24, which would be nice. So really, to get a denominator of 24, this right half, I need to multiply by 2 divided by 2. Now, I'm really multiplying by 1 there, but it's going to change the form of the problem so we can add up these two fractions. Same thing, I need a denominator of 24 down there. It's 8 right now, so I'm going to multiply by 3 over 3. So if I do this, up top, I would have 9 over 24 plus 10 over 24. And now those two add together nicely. I get 19 over 24, and I've got it. Right, so you've probably done that before. Are you getting a common denominator? It's just what we're doing today would be a little tougher than just a basic problem like that. We'll have stuff like this, right? So let's start with a little bit more difficult. I don't really see anything factoring here, so we're just going to go with this one. So I need a common denominator between all these. So first, let's just look at the numbers. So if you have a 2, a 6, and an 8, what are the common denominators, which are 2 and a 6 and 8, a common multiple? So the 2 is going to multiply into any of those. And really, I'm just looking at the 6 and 8. So 6, 12, 18, 24, etc. 8, 16, 24, etc. There it is, 24. So 2 goes into 24 as well. So that's our common denominator. So I need a 24. So just looking at the numbers there, I'm going to need to multiply this one by, let's see, to get 24, same thing, right? It's going to be 3 over 3. I get 24 here. I'm going to get, let's see, that would be 12 over 12. And here, so this one, I'm going to multiply by 12. Let's see, I need to get 24, so 6 times 4, so 4 over 4. Okay, so now let's talk about the variables. So I have one of them's an a, and one of them's an a squared, one of them doesn't have an a. So of the common variables, I need a squared for everything. I need a common variable. So this one's going to need an a squared. It doesn't have any a. This one is going to need one a, because it only has one. This one has all the a's it needs, right? Let's now look at the b's here. So we have a b and a b squared, so I need a b squared. So this one has everything it needs. This one needs one b, it's lacking a b. And this one needs two b's, so b squared. I think now all of these will have actually the same denominator, right? So I'm going to have 4b squared over 4b squared, or sorry, 24a squared b squared minus 12ab over 24a squared b squared plus, I think there's a plus there, 9a squared over 24a squared b squared. And now I can combine this into one fraction, right? So I've got 4b squared minus 12ab plus 9a squared, all divided by 24a squared b squared. So I'm going to try to factor that because I have a feeling it might factor here. I have that feeling because the first and last term are perfect squares. So I'm just going to try this. I don't know if it'll work, but sometimes these things do. So the square root of 4b squared is 2b. So I'm hoping that's going to be 2b. And the square root of 9a squared is 3a. So 3a and 3a. And it looks like that's plus, that's minus. So maybe minus, minus. This would be negative 6ab minus 6ab. I think that does work. So does anything cancel? Does that help us at all? It might not. Well, 2b minus 3a, we could be cool and write this, it's the same factor twice. So if we wanted to be cool, we could write it as 2b minus 3c squared. I think that's about all we can do. So that's as simple as we go. If you wanted to state restrictions, a cannot equal 0, b cannot equal 0, because that would make the denominator 0 there. Okay, so factor first, because that might help us here. So we're going to try to factor that first. We have 3 over, let's see, that should factor, not too bad. So x and x, probably 3 and 2. Bigger one is positive, maybe that. And then 2 over x and x, 2 and 1, minus and minus. Okay, so let's try to see how many things we have in common. We have an x minus 2, so that's good. We have that. Ooh, this one has x plus 3, but the other one doesn't. This one has x minus 1, but the other one doesn't. So we'll have to remedy that. So this one needs the x plus 3 to have the same denominator. This one over here needs an x minus 1. And I'm multiplying here, x minus 1. So that's multiplied by that, it's multiplied by that. One smart move you could do, you could make this a plus and move that negative up to the negative 2. It just makes it a lot easier to distribute here and solve the problem a little bit here. So we get 3x in the numerator, 3x minus 3 plus negative 2x minus 6 all over, because this really is now the same denominator, x minus 1, x plus 3, x minus 2. I'm going to simplify that numerator a little bit, so I get x minus 9 over x minus 1 times x plus 3 times x minus 2. Hello? Yeah. The domain, if they ask for it, is all reals, but x cannot be, there's a few values it can't be. So x can't be 1, can't be negative 3 or 2 here. Look at that denominator, because you want to look at all 3. Okay, we're getting a little bit more complicated to see what happens here. So, but this isn't too bad, right? So let's kind of look at this. So first we got a factor. So 2 times, hopefully that factors, I think it does. X and x got to be 3 and 2. Bigger number is positive, okay? Plus 1 over x plus 3. And plus, I'm giving myself a little room there just in case I need to multiply. 1 over x minus 2. Okay, so let's see what we have. We have an x minus 2 for these two. We have an x plus 3 for these two. So I think I have my common denominator. I'm going to need, well, that guy doesn't need anything. This guy needs an x, is missing an x minus 2. Now that's going to have the same denominator. This one's missing an x plus 3. And again, that's being multiplied, that's being multiplied. So I get 2 over x plus 3, x minus 2, plus x minus 2 over x plus 3, x minus 2. I guess I could have just moved these together. Plus 3x plus 9 over x minus 2. X doesn't matter the order, x plus 3. Okay, now I'm going to add up all the numerators. So I get 4x plus 9, I believe, over x minus 3, or x plus 3 times x minus 2. And so the restrictions are x cannot equal negative 3 and x can't be 2. Part B, again, you want to start by factoring because that sometimes makes our life a little easier. So let's factor that. So we get x over x minus 1 plus, I'm kind of hoping like one of these is x minus 1 when I factor. So I get x and x, 2 and 1, minus minus. Okay, let's see what we got. So this one is matching. This one is different. I think I know what I need. Over here, I am missing an x minus 2, so I'm going to multiply by x minus 2. And you get, that distributes, right? So you get x squared plus or minus 2x plus 2x minus 1. Let's just go ahead and combine those. Might as well. And so I get, see, x squared. Oh, wow. Oh, this is going to be interesting. X squared minus 1. Oh, I like that. X minus 1 times x minus 2. The reason I like it is that actually factors, right? So we get x plus 1, x minus 1. Oh, this is a nice problem. X minus 1, x minus 2. So what's going to happen is the x minus 1s are going to cancel, and you're left with x plus 1 over x minus 2. And the denominator, x cannot equal, the restrictions would be 1 and 2. Those would be the two values. Even though I canceled out, it still has a restriction there. These are kind of tough sometimes when you have something like this in the denominator, because a lot of times students just forget the fact that you can take out a GCF. So x plus 2 over x times x minus 2 minus x plus 2, 2 times x minus 2. By the way, I might just consider doing this. I might change this to a plus and distribute that up top. So just so I don't forget about all the negatives that could get more complicated, I think it might be smart just to do that first. And then let's see what happens here. So what do I have for a common denominator? I have an x minus 2, that's common to both. I have an x that one has, but not the other one. And I have a 2 that one has, but not the other one, right? So I think we know what we need to do here. So this one needs a 2. This one needs x. And so we'll have, this distributes here, so it'd be 2x plus 4. This one distributes here. We get negative x squared minus 2x. And this is 2x times x minus 2 down there. Does that simplify at all? So 2x minus 2x is good. So I get 4. Ooh, I like this. 4 minus x squared. I like that. So this is going to be a really interesting problem. So we have some more work to do. So I didn't expect it quite to go this tough here. So, but it does sometimes. So this is going to be difference of squares. So 2 and 2. Square root of x squared is x and x. One of them is plus, one of them is minus. It's a minus right there. One of them is plus, one of them is minus. Okay. And we get 2x times x minus 2. Now you can see this is so close to being what we want. Like I have an x minus 2 and I have a 2 minus x. If I pull out a negative, so pull or factor out a negative there, what should happen, so I'm going to put a negative in front of the numerator. So this is going to be 2 plus x. This is going to be, instead it's going to be negative 2 plus x when I pull out the negative over 2x times x minus 2. So now, I don't know if you see it, but those two do cancel, right? I have positive x, negative 2, those cancel nicely. And so we're just left with, I'm just going to change the order just because I can here. So it'll be negative x plus 2 over 2x. And again, if they ask for the restrictions, x cannot equal 2 and x cannot equal 0. Those would be the two values from those two factors right there. One more example, I believe. Nope. I think we're good, actually. That's the lesson. Real quick, let's do this one. So what's the average of those guys? Stop it, take a stab at this one, and we'll do it. Let's see. So x is the average of m and n. So if I average m plus n, if I add them up and divide by 2, I get x. If I add up 2m plus 15 and divide by 2, I get y. That's the average. If I average 3m plus 18 over z, over 2, that's a 2, equals z. So that's a 2 there. So what is the average of x, y, and z? So if I add those three up and divide by 3, so add up this, plus this, and divide that by 3. So that's going to be, if I add up all the m's in the numerator, that's going to be 6m plus 9 plus 15 is 24, 34, 42, I think, all divided by 2. So I have to add those up. I add those up. I'm going to divide all of that by 3. Does that kind of make sense? But divided by 3 is like multiplying by its reciprocal, right? So I'm going to multiply this by 1/3. So I get 6m. Well, let's simplify that. So do you see a GCF there in the numerator? So it'd be 6 times m plus 7 over 6. And the 6's cancel. Wow, you get m plus 7. Isn't that so nice? M plus 7 is our answer. You could have plugged the numbers there as another way of going. You can actually just choose a value for m. And then, kind of find those averages and see which answer matches. That's another way of doing it. That's your lesson.